Hello. Today's lesson is about the difference between weight and mass and how you can calculate weight using your reference tables. So we've learned before that mass refers to the amount of matter or stuff that we are made out of. And this number does not change depending on where you are, whether on Earth or in space or the moon, because the stuff that you're made out of is the same. You have the same atoms, whether you're here or there. So if you have a mass of, 100 kilograms, that's going to stay the same no matter where you are. What will change is your weight, which is the force that you feel due to gravity. Weight is a force that changes depending on what planet you are on, quote unquote. Because weight is the force you feel when all the mass that you're made out of is accelerated due to gravity. And that can change depending on how strong is the gravity. How much does gravity make you accelerate? So kind of a trick question that you might see on the Regents, a mass of a 50 kilogram object is taken to the moon. Compared to its mass on the Earth, the object's mass on the moon is, and the trick answer is smaller. And you might think it's smaller because the moon's smaller, gravity's smaller, but because gravity is smaller, that means the weight is less, but the mass is the same. They're asking about the mass. Whether it's got 50 kilograms of mass in it, it has 50 kilograms of mass on the moon as well. So what changes is the force the object feels depending on where they are. So on Earth, this is what acceleration due to gravity makes how falling objects move. More acceleration, more weight, more forces. These falls that you're seeing would hurt more because the objects are experiencing more force. And so when they hit something, it hurts more. Whereas on the moon, same adult humans, roughly the same mass, the same atoms, but because acceleration due to gravity is so much less, they're experiencing that much more force, and a fall like this would not hurt as much, but it would be dangerous if they got a hole, got a little hole in their knee, and then, so this is actually super dangerous for an astronaut. So on the moon, you would have the same mass, but you would have less weight because there's less acceleration towards the center of the planet, moon. Okay, so how can we do some math with this? In your reference tables, you already have Newton's second law. Acceleration is the net force divided by the mass. I already learned about this before. Basically, the more force that's acting on an object, the more it accelerates. The more mass the object has, the less it accelerates. And on your reference tables, right near Newton's second law formula is the weight formula, which is basically just Newton's second law formula, but specifically when we're talking about the force due to gravity. So Newton's second law was started with the acceleration, and the weight formula, gravity is just acceleration due to gravity. That's annoying. I want to change my color. I can't. Oh, well, that's zoom. Sorry. And then in Newton's second law, you have the net force on top on this side. And in the weight formula, you also have a force. Instead of the net force, it's the force due to gravity, AKA the weight. And then both formulas have the mass because the more mass you have, the less acceleration. So just like Newton's second law, this is a really simple formula. You've got three variables. You'll know two, and you plug them in and solve for the one you don't know. So for example, what is the weight of a 3.5 kilogram object? Nice and simple. The question gives us one variable, 3.5 kilograms, that's the mass. And they don't tell us gravity, the acceleration due to gravity. So when they don't say anything about where this is, assume this is on Earth. they'll say if it's on the moon or in space or on a different planet. So we know that gravity is 9.81 meters per second squared. That's the acceleration due to gravity. And the thing we don't know is the force due to gravity, AKA the weight. Weight is force due to gravity. So we plug our numbers in to the formula and we solve for the variable we don't know. In this case, put this over 1, cross multiply. It's nice and ugly. And 3.5 times 9.81 is 34. And the units of force are newtons. So in scientific units, your weight should be in newtons. So that's the formula. That's the basic concept of weight versus mass and how to use the formula. I have shared with you a link to what do scales actually measure. So if you look at a scale and think about what a scale is measuring, is it measuring your mass or your weight? Like the way it works, it's measuring the force of the earth accelerating you down, like you're pushing down on the scale because of gravity. So scales are actually measuring your weight, but then short version is whoever makes the scale basically converts the force units to kilograms or grams or pounds so that you can read it and it makes sense. So you can read that if you want to. Your assignment is really straightforward. There's just 4 questions where you have to use the formula for weight. It's on your reference table, it's in your notes. It should be pretty easy. Good luck, and let me know if you have any questions.